50 million people. That is the number. Not from a war, not from a plague, from the sky, from the ocean, from a shift in the Pacific so profound it silenced an entire planet's harvest at once. The year was 1877. And what happened next is the most lethal climate event in recorded human history. In this video, we are going to follow that catastrophe from its quiet beginning in the depths of the Pacific Ocean to the famines that consumed 3 continents. We are going to meet India at the moment her monsoon disappeared. We are going to watch Brazil's rivers dry down to sand. We are going to stand at the edge of what historians call the Global Famine and understand exactly how the ocean caused it. And then we are going to look at what NASA and NOAA are watching right now in 2026, because the Pacific is doing it again. If you want to keep watching events like this as they develop, subscribe. We will be here every step of the way. The ocean has done this before. The question is what it will do next. The summer of 1876 begins quietly. Across the Indian subcontinent, 250 million people go about the rhythms of a life built around one thing, the monsoon. It comes every June. It has come every June. For thousands of years, the southwest monsoon has been as reliable as sunrise. Farmers plant in anticipation of it, governments budget around it. Children are born into a world where summer means rain. In the Deccan Plateau, in the Punjab, in Madras, in Bombay, the fields are prepared. The seeds are ready. The rhythm is trusted. That summer, the monsoon is late, then it fails, not everywhere at once. At first, it is just dry patches. Reports from local administrators of reduced rainfall. Concern, but not panic. Monsoons have been late before. They always return. But in the depths of the equatorial Pacific Ocean, something has already shifted. Something nobody in 1876 could see, measure, or name. A vast pool of warm water, normally pinned to the western Pacific by trade winds blowing steadily from east to west, has begun to slide. The winds have weakened. The warm water begins to move east, slowly at first, then with gathering force. Nobody knew. Think of the Pacific Ocean as an enormous tilted bathtub. The trade winds act like a finger holding the water toward one end. The western Pacific stays warm, the eastern Pacific stays cool. That tilt drives the monsoon systems across Asia and regulates rainfall on 3 continents. Now imagine someone lifts that finger, the warm water slides east, and everything built on the old pattern collapses. Here is what makes this terrifying. Under normal conditions, the Pacific Ocean is a machine. A very large, very slow, very precise machine. The trade winds blow from east to west. They push warm surface water toward Indonesia and Australia. That warm water evaporates into the atmosphere. The moisture travels, rain falls in India and China and Brazil. The machine runs so consistently that entire civilizations grow up inside it. Now imagine someone turns off the machine. When the trade winds weaken, the warm water that was pinned to the west begins moving east. This is not a small shift. We are talking about a volume of warm water the size of a continent, tens of millions of cubic kilometers, changing direction. When that water arrives in the central and eastern Pacific, it heats the atmosphere above it. That heated air rises. It pulls moisture toward South America instead of toward Asia. The jet stream shifts, storm tracks relocate. The machinery that delivered monsoon rains to 500 million people simply stops delivering them. This is El Niño. And in 1877, it was not a normal El Niño. Scientists who have reconstructed the 1877 event from tree rings, coral records, and historical documents describe it as the strongest El Niño in at least 150 years of recorded data, and possibly in centuries. Sea surface temperatures in the Central Pacific rose to levels that dwarfed any modern event. The warm water anomaly was not a ripple. It was a wave across the entire ocean basin, and it triggered droughts simultaneously on 3 continents. Not sequentially, not one region at a time, all at once. India, China, and Brazil all stopped receiving the rains they depended on in the same years because of the same ocean signal. The scale of what was coming was beyond anything the world had ever faced, and nobody had a name for it yet. India feels it first. It is June 1877 and the monsoon does not arrive. Farmers in the Deccan Plateau wait. July passes. August passes. The wells begin to drop. The rivers shrink. By September, the dust is so thick in parts of Madras that visibility falls to near zero. In the fields, the crops are dead. The British colonial administration receives the reports. The response is slow. Grain exports continue. An estimated 320,000 tons of wheat shipped out of a starving subcontinent while the famine deepens. Relief efforts are designed to minimize cost. Work camps are established where the starving must labor for meager rations. The rations are deliberately kept below subsistence level on the theory that generosity would encourage dependence. People begin to die, not dramatically, quietly, first the weakest, then the elderly, then the children. Dysentery moves through camps already weakened by hunger. Cholera follows the drought like a shadow. Smallpox ignites in crowded relief stations. By 1878, the famine has spread northward, the central provinces, the northwestern provinces. An area of 670,000 square kilometers, larger than France, is engulfed in hunger. An estimated 58 million people are living inside the famine zone. The death toll in India alone reaches between 6 and 10 million people. But India is only one part of this story. 14,000 kilometers away, China is dying too. The northern Chinese famine begins in 1876. In the provinces of Shanxi, Henan, Shandong, Hebei, and Shaanxi, the rains fail. These are not small provinces. Combined, they hold a population larger than most nations on Earth. The Yellow River, the river of life for northern China, drops to a trickle. Harvests fail completely in 1876, then again in 1877, then again in 1878. 3 consecutive years without rain. The Qing dynasty government is stretched to breaking, infrastructure collapses. Relief cannot reach interior provinces. Roads are impassable. The state granaries are empty. Cannibalism is documented in multiple provinces. The death toll in China, between 19 and 30 million people. In the province of Shaanxi alone, historians estimate that between a third and half of the entire population dies, and still the ocean is not finished. In the dry scrublands of Brazil's northeast, in a region called the Nordeste, the drought arrives with devastating precision. The rainy season of 1877 simply does not come. The São Francisco River drops. The reservoir is empty. The cattle die first. Their bones bleach white in riverbeds that used to flood every season. This region of Brazil is called the Sertão. Its people are called Sertanejos. They are resilient. They have survived droughts before, but not like this. 2 million people die in the Grande Seca, the Great Drought. Survivors walk hundreds of kilometers toward the coast. Mass graves appear along roadsides. The Brazilian government, watching its northeast depopulate, is essentially powerless. The infrastructure to move food from the coast to the interior does not exist. The drought is simply too vast, too fast, and too complete. 3 continents, 3 famines, 1 ocean signal. The total death toll from the global famine of 1876 to 1878 exceeds 50 million people. 50 million. That number represents roughly 3 to 4% of the entire human population of Earth at the time. Scaled to today's world population, an equivalent catastrophe would kill an estimated 250 million people. 50 million. But here is the part that makes the stomach drop. The 1877 El Niño did not act alone. Scientists who have analyzed the historical record have discovered something that took more than a century to fully understand. In 1877, the El Niño in the Pacific was reinforced by 2 additional ocean systems firing at the same time. The Indian Ocean Dipole, a temperature seesaw between the western and eastern Indian Ocean, flipped to its most extreme positive state ever recorded, before or since. That pushed additional drought toward India and southern Africa. And the North Atlantic, in 1877 and 1878, was the warmest it had ever been since records began. That warmth pulled moisture-carrying atmospheric winds northward, away from the Brazilian Nordeste. 3 ocean systems, all amplifying each other, all pointing in the same direction. It was not just a strong El Niño. It was a strong El Niño with accomplices. The atmosphere, the Pacific, the Indian Ocean, and the Atlantic all conspired against human civilization in the same 2 years. The odds of that happening by chance are extraordinarily small. Scientists still debate exactly why it happened. What they agree on is this. When multiple ocean systems reinforce each other, the impacts are not just additive, they are multiplicative. The 1877 event was not simply twice as bad as a normal El Niño. It was categorically different. It operated at a scale that exceeded the coping capacity of every civilization it touched. And scientists are watching for this alignment again right now. Now look at what is happening in 2026. On June 11, 2026, NOAA officially declared an El Niño. Not a mild one, not a moderate one. Forecasters are using the word super. The trigger was visible from space months before the declaration. NASA's Sentinel-6 satellite began detecting massive warm Kelvin waves crossing the Pacific in early 2026. Continent-sized pulses of heated water moving eastward from the western Pacific toward South America. By mid-May, sea levels off the coast of Peru were already 15 centimeters higher than long-term averages. Not because more water arrived, because the water was warmer. Warmer water expands. The ocean is physically rising off South America because of heat moving beneath its surface. By June 8, researchers at NASA's Jet Propulsion Laboratory compared satellite imagery of the Pacific to historical records and found something striking. Conditions in the western Pacific that month looked almost identical to conditions from the same date in 1997, the year the strongest modern El Niño on record emerged. The 1997 to 1998 El Niño killed an estimated 23,000 people and caused $37.5 billion in global damage. And current models show 2026 tracking to exceed it. Over half of current forecast models project that sea surface temperatures in the central Pacific will rise more than 2.5 degrees Celsius above average by autumn. That threshold would constitute a historically strong event. The European Center for Medium-Range Weather Forecasts NOAA, Japan's meteorological agency, and Australia's Bureau of Meteorology are all converging on the same forecast, a convergence forecasters describe as unusually strong. NOAA now puts a 96% chance of El Niño continuing through December 2026. The event is expected to peak between October 2026 and February 2027. The WMO reports subsurface water temperatures in some areas of the tropical Pacific already running more than 6 degrees Celsius above average, a vast reservoir of heat moving steadily toward the surface. The FAO and the World Food Program have already launched a joint emergency appeal, $202 million to protect 8.8 million people across 22 high-risk countries before impacts escalate. They are not waiting, they are pre-positioning, and scientists are watching 3 regions with particular alarm. India's southwest monsoon, the agricultural heartbeat of a nation of 1.4 billion people, is under direct threat. Strong El Niño events have historically weakened the monsoon, reducing rainfall across the subcontinent during the critical growing season for rice and maize. India's agricultural sector, which employs hundreds of millions of people and underpins enormous portions of the national economy, runs almost entirely on that rain. When the monsoon fails, the ripple effects move through food prices, rural incomes, hydropower output, and social stability simultaneously. In Indonesia and the Philippines, where rice supplies feed hundreds of millions, and where El Niño historically reduces rainfall sharply, crop failures could push global rice prices higher at exactly the moment when households in those countries are least prepared to absorb them. In Australia, the Murray-Darling Basin, one of the world's most productive agricultural regions, faces drought conditions that could reduce yields significantly. The 2019 to 2020 Black Summer bushfires, which burned 18 million hectares, occurred during El Niño-influenced drought conditions. Climate scientists are already flagging elevated fire risk for late 2026 and 2027. The European Union's Joint Research Centre published a report in June 2026 warning that for the most extreme scenario currently being modeled, their systems are extrapolating beyond any historical precedent. Beyond any historical precedent. That is what the data is showing right now. The outcome that 3 continents are not ready for is not dramatic. It is not a single catastrophic event, it is food. The 1877 El Niño did not kill 50 million people with storms. It killed them with hunger. It disrupted the agricultural systems that billions of people depended on, quietly, invisibly, across multiple growing seasons, until the gap between supply and need became unbridgeable. Today's world is more connected than 1877. Supply chains span the globe. A drought in Thailand raises rice prices in the Philippines. A failed monsoon in India moves commodity markets in Chicago. A crop failure in Australia affects bread prices in Egypt. The connections that make the modern food system efficient are the same connections that make it fragile. The 1877 event operated on a planet of 1.4 billion people. The 2026 event is developing on a planet of 8 billion. With more mouths to feed, more climate stress already accumulated, and agricultural systems already running closer to their limits than at any point in history. Scientists are not saying 2026 will be 1877. The data does not say that. What the data says is this. The Pacific looks more like 1877 right now than it has at any point in nearly 150 years. Multiple agencies, multiple satellite systems, multiple independent forecast models are all pointing in the same direction. The event is developing, it is strengthening, and the 3 regions most at risk, South Asia, Southeast Asia, and Sub-Saharan Africa, are the same regions where food insecurity already exists, where conflict and economic stress are already elevated, and where additional disruption has the least margin for absorption. Is the world ready for that outcome? The FAO launched a $202 million emergency appeal before the El Niño even peaked. The WMO Secretary General called on governments to prepare immediately. The EU Joint Research Centre is modeling scenarios that exceed anything in the historical record. Those are not the actions of agencies that are confident we are ready. The ocean has done this before. 149 years ago, it reshaped the world. It did not announce itself. It did not ask permission. It simply shifted, slowly, invisibly, deep below the surface, and then released everything it had stored. What is building in the Pacific right now is the same mechanism, the same force, on a larger, hotter, more populated planet. The question the data is asking us right now is whether the world we have built is more resilient than the one the ocean dismantled in 1877, or whether our connections, our supply chains, and our already stressed agricultural systems have simply made us more efficient at sharing a catastrophe across continents. Subscribe and drop a like if you want to keep following this as it develops. It helps more than you know. We will be watching.